Good morning, good morning. Good morning, everyone. Come on, bacha buddy. Can you hear me? Am I audible? Are you able to hear my voice? Sweet voice. Good morning, bacha. Good morning. चलो भाई मैराथन गोल्ड स्टार्ट किया जाए. All good. Okay. Marathon T1 part 1 has been completed. Part 1 has been completed. Now marathon track 1, physics marathon track 1 part 2. We will start from electric potential and capacitance. These days they are making movies also in 2 parts. है ना, बाहुबली पार्ट 1, बाहुबली पार्ट 2. क्या कार्तिक सर ऑडिबल? Okay, wait. Some sound problem. Here it is okay. Yes, Gyan Prakash, it's Dhurandhar 1. AKD sir, you have seen the movie. Dhurandhar 1 you have seen. Now it's part 2, Dhurandhar, the revenge. Bahubali, the beginning we have seen. Now it's time for the conclusion. Some problem in campus? Okay, so what I have, instead of scrolling the NCRT, what I have done, I have important short notes, which will be helpful for you. Try to keep the important formulas, important varieties of the questions here. Okay? Because scrolling the NCRT, selecting the important points, it will take some time. Okay? Time is something which we don't have right now. Okay? So I have made last night only, it took me almost 3 hours, 3.5 hours. So I think it will be completed in 3 hours. Okay? So without further delay, let's start. Dekh bacha, even those students who are fighting for, let's say, 80 marks or 100 marks, okay, I can challenge, I can tell you that in NEET exam 2026, there will be some question. 70% of the physics paper is supposed to be easy. Don't take 25 or 16. Year 2016 and 2025 reference. They are not reference paper. They were the revenge paper. When some controversial thing happened in 2015, 2016 paper came tough. Something controversial happened in 2024. That's why 2025 paper was tough, right? It will not happen every year. And in the 2025 paper, individual questions were doable. The entire 45 questions were not doable in the limited time. But individual questions were doable. AKD sir told you, we find some question in the NCRT only, right? That means you will find them in notes also. Okay, but a normal paper of NEET, 70%, almost 120 marks I can guarantee, and it will be easy. Okay, easy. Now, what makes any question easy? As I've already told you, easy question means either its mathematics applied will be less. Tough question means there will be more mathematics in it. First thing. Second point, easy question means you have already seen it. Understand? Some tough question is there, we have already discussed in the class. Now, second time when you attempt the same question or the same pattern question, do you think the difficulty level will remain same? I don't think so, right? That means the same question which was appearing tough to you, after solving, after seeing that question, second time, similar question appears a little bit easier. Although the mathematics is still tough. But since we have done it, now it is easy. That means to make any question easy, you have to see it. You have to make the question seen. And how will you make the question seen? You solve a lot of questions. That's what we will do in the face exam, grand test. We will try to give you exposure of so many varieties of the question. Okay? So that any question which comes in NEET, most of them you should be able to see it. Same I'm trying to do here also. Same thing I'm trying to do here. Okay? I have brought some important questions, important formula. Then you will see some NCRT example also. Those who are NCRT fan, I have brought NCRT example also. Separate. Can we start? Sir, can we get that PDF? I will try. I will send it. So the question is, are we ready? चले स्टार्ट करें, चलो. सो फर्स्ट थिंग इज, पेन का है भाई इधर, ओके. सो फर्स्ट थिंग इज पोटेंशियल ड्यू टू point charge. Potential due to point charge, we know the formula V equal to KQ by R, है ना. V equal to KQ by R. We all know कि it is a scalar quantity. It is a scalar quantity. So we will not try to associate any direction with it. Correct? We will not try to associate. कि sir positive charge potential direction is away from charge, negative charge towards the charge. No, it is a scalar quantity. It doesn't have any direction. Now, if it's a positive charge, then potential produced will be positive. If it is a negative charge, potential produced will be negative. Positive charge will produce positive potential, negative charge will produce negative potential. Means here the Q value you will put with sign. This basic thing we know, है ना. We will have to put the Q value with sign. Negative charge, negative sign we will put. This we don't do in electric field magnitude, electric force magnitude, right? In electric force, K Q1 Q2 by R square. Electric field, KQ by R square. We do not take the negative sign of the negative charge. But in potential and potential energy, we will do it. Okay, bacha buddy? ठीक है. Now, what if multiple point charges are present, sir? Multiple point charges. Then find individual potential and add them. Like first charge K Q1 by R1, second charge K Q2 by R2, and similarly. Okay. Moving ahead, what type of question based on this concept? So let's say they say, and a very important type of question, n charges are placed at corners of regular polygon. Regular polygon means sides are equal, side length equal. Okay? So like see Q1, Q2, Q3, Q4, Q5. So what you will write potential at the centroid? KQ2 by R, where R is the distance. Please remember it. R is distance of the charge of the corner from the centroid. Distance of the charge or the corner from the centroid. R is not the side length. Here you can do mistake. R is not side length. R is distance of the charge from the centroid. So what we can write in short? K Q total by R. K Q total by R. If some negative charge is there, then obviously we will subtract. Positive charge plus negative charge minus. So we have to subtract also if negative charge is there. That means if they say potential here is zero, if they say potential at the centroid is zero, it means one thing. Q total should be also zero. Means some positive, some negative, and the Q total should be zero, then only potential will be zero. Now, this is the story at the centroid. What if they ask at a point on the axis? Come on, understand. At a point on the axis, here at the distance x. Refer this diagram. The polygon is drawn on this ground, and the point is on some height x, above some height x above the centroid. Then the formula is KQ total divided by x square plus r square under root. What is this distance? This one. Understand it? This distance is x beta. This one is r. Then distance of the point from the charge will be under root x square plus r square. Okay, so KQ total by under root x square plus r square. Okay, bacha buddy? But regular polygon, all sides must be equal. Okay, means this is not valid for rectangle, only valid for square, only valid for equilateral triangle, not isosceles triangle. Moving ahead. Next type of question they ask, zero potential point. They will give you two charges and they will ask, you find on the line joining charges where the potential is zero. Some cases we can see. If there are like charges, Q1 and Q2 both positive, Q1 and Q2 both negative. So here chances of doing mistake is high. Please understand, both positive, then both will produce positive potential. Both negative, then both will produce negative potential. That means their potential will never cancel. You can't say, sir, one in this direction, one in this direction. No. You can't give direction to the potential. So potential will become zero only when some potential will be positive, some potential will be negative. Right? So for that, some charge has to be positive, some charge has to be negative. So potential will be zero only in case of unlike charges. ठीक है बच्चा buddy? So in case of like charges, no zero potential point exists. So far so good. Coming to the unlike charges. Unlike charges, case one, if they have same magnitude. Unlike charges, if they have same magnitude, then on the line joining, it will be just in the middle, right in the middle. So on line joining charge, there will be only one zero potential point. But if they say in the entire space, how many points? Obviously, there are infinite points. Because here also, potential will be zero, here also zero, here also zero. Everywhere on this line will be zero. In fact, not only on the line. You can imagine a plane. You can imagine a plane coming out of here. So potential everywhere on this plane will be zero. So if they ask in space, there will be infinite points. But if they ask only on the line joining, there will be only 1 point. अरे समझा भाई? क्लियर है? आगे चल सकते हैं? चलो. Now come to different magnitude. Now this is the question. If Q1 and here a charge minus Q2, and I'm saying Q1 is a stronger charge, Q2 is a weaker charge, not because of the minus sign. Please understand. If it is a 4 coulomb and minus 9 coulomb, this is a strong charge. This is strong charge. Don't say sir minus sign. No. Plus and minus only tells about the nature of the charge. Okay? If you want to know which one is strong charge, then just see the magnitude. Okay? That's why I placed a mod here. So I'm saying Q1 is stronger than Q2. Then null point, two null point will exist. How many? Sorry, null point. Sorry. Two zero potential point will exist. Null point we say where field is zero. Potential is zero, we will call it zero potential point. So two zero potential point will exist. One will exist between the charges. Another one will exist outside the charges. But both points will be closer to the smaller charge. Both points will be closer to the smaller charge. So let's say we are interested in distance of these two null point, these two zero potential point from Q2, from minus Q2. So one I'm calling it X, another one X dash. So the formula of X goes like this. Q2D divided by Q1 plus Q2. Mod. Negative means you take it positive. Okay. Q2D divided by Q1 plus Q2. And here Q2D divided by Q1 minus Q2. Sir, in numerator, which charge to take? Q2 or Q1? How do we decide? In numerator, which charge will be there? That charge from where you are measuring the distance X. Like, I have measured the distance of zero potential point from minus Q2. That's why Q2 here. If I'm interested in this distance, let's call it Z or Z dash. Then Z I will write Q1 into D divided by Q1 plus Q2. Means which charge in numerator? That charge from where we are measuring the distance of the zero potential point. Okay? Similarly, X dash, the outer one, it will be Q2D divided by Q1 minus Q2. Remember, here Q1 plus Q2, Q2 plus Q1, it doesn't matter. But here it matters. Always do bigger minus smaller. Q1 was bigger, do bigger minus smaller because I want to make the entire thing positive. Negative value of X dash will not make any sense. So numerator we will take that charge from where we are measuring the distance of the zero potential point. Here denominator I will take bigger minus smaller. Here denominator you can take whatever you want. Okay? So these are two zero potential point. Okay? Question is given in NCERT, we will come back there. Now potential due to ring. Add center KQ by R. It is just like polygon wala formula. Because ring is nothing but a regular polygon of infinite sides. Topper student, please listen. Ring is nothing but a regular polygon of infinite sides. So that KQ by R formula will be still valid. And that kq by under root x square plus r square formula will be also valid. Same thing you can apply in field also. Electric field, the ring formula will be valid in regular polygon provided the charges are equal. Same field formula you can apply. Okay, anyways. Then, in some question they will say left side positive, right side negative, equal amount. Then what will potential at the center? Come on, tell me. Left side positive, right side negative, equal amount. What will potential at the center or anywhere on the axis? It will be 0 because Q total will be 0. Very good. 0, 0. Nice. Very good. Chalo. That means you are with me. Then potential due to hollow sphere. So inside point, if you take a sphere of radius capital R, one point you take inside at a distance small r, another point you take outside at a distance small r. So inside point it's kq by capital R. Outside point kq by small r. Now that means inside point it is constant because I'm finding at a distance smaller only. But small r is not there in the answer. Capital R means if I take another point inside, another point inside, another point inside, center only. But everywhere answer will be capital R, which is fixed. For this point also, every point this is fixed. So this is a constant. That's why the graph, I will tell you the graph. Outside point it is kq by small r. Come to this solid sphere, non-conducting. Because if it is a conducting, the charge will be on the outer surface. So conducting solid sphere, you will take hollow only. We know this thing, right? So inside point, it will be 3r square minus small. Okay. I hope I am audible, bacha buddy. Chalo, so I was discussing this question. It's a non-conducting solid sphere. Charge is given, radius is given. They are asking to find potential at distance of 5 centimeter from the center and 20 centimeter from the center, right? So now due to solid sphere, we know the potential formula. But the problem is we know two formula. And given point, they're asking the question, is inside point or outside point, correct? Now, how to find? You have to check the distance r is less than r or greater than r. So the radius is 10 centimeter, radius is 10 centimeter, and they are asking you to find at the distance 5 centimeter. That means clearly 5 is less than 10, so r less than r, so this is inside point. This one is inside point, so we'll apply V equal to K. We will apply V equal to K, Q I will write 10 power minus 6 by 2 R cube, R. We will write 0.1 centimeter whole cube. Then 3 R square, which is 0.1 whole square minus small r square, which will be 0.05 whole square. We can do the calculation, we can get the answer in volt. But in the second one, V2, we know 20 centimeter is more than 10 centimeters, so this is outside point, so we will use K, Q by small r square. Small r square means 20 centimeter, 0.2 whole square. Okay? So this is how you identify whether a given point is inside point or outside point. Let's say they have given you a question where the center of the sphere is at origin. Center is at origin, and they're asking find potential at 8,8 centimeter. 8,8 centimeter. Now, 8,8, sir, how to know this is inside point or outside point? You may get a feel, ki, sir, 8 and 8, both are less than 10. 8 centimeter, both are less than 10. So I think it's an inside point. No, you are wrong. Means you may be right, you may be wrong. We don't know. Find the distance from the center. Find small r. So small r will be 8 minus 0 whole square. 8 minus 0 whole square plus 8 minus 0 whole square. You know the distance formula. It will become 8 root 2. Root 2 is 1.414, which is, I think it is more than 10 centimeter. Okay? So this is more than 10 centimeter. Right? That means this is outside point. We must use the formula of outside point, not the inside point. But by looking at the coordinate, sir, both coordinates are less than 10, so inside point. No. The distance, find the distance, it is 8 root 2, which is more than radius, 10 centimeter. Okay, I hope you understand this. Coming next. 4q charge on the inner, all are concentric cells. 4q charge on the inner, minus 2q in the middle, and 3q on the outer. Find potential of middle sphere. Find potential of middle sphere. To understand. Now it is question of hollow sphere. Hollow sphere inside point kq by capital R, and outside point. Achha, one mistake I have done. I have taken r square. Sorry. I have taken r square. I should have taken r. kq by r square, kq by r. My mistake. I apologize. Okay. Now, bacha middle one, let's say this one. So what you will write? You will write potential of this point. So for 4q charge, 4q charge, this point is outside point. So we will write k 4q divided by total distance is 2r. Don't do the square. Then for minus tq, it is surface point. So we'll write plus k minus 2q divided by surface point. It will be 2r. Okay? And then plus k 3q divided by, for 3q charge, this is inside point. For 3q charge, this is inside point. Inside point, the formula is kq by capital R. kq by capital R. So it will be the radius of the 3q charge. Radius of the 3q charge is 3r. And then we can solve it and we will get our answer. Next. Electrostatic potential energy. So first of all, we will start with two particle system. Two particle system potential energy is written as k q1 q2 by r. K q1 q2 by r for two particle system. But sir, if there are n particle system, then how to write the potential energy? You try to form number of pairs. How many pairs will be formed, sir? So total number of pairs which will be formed in n particle system will be n into n minus 1 by 2. That means, in case of triangle question, the charges are kept as a triangle, then total n is 3. So it will be 3 into 3 minus 1 by 2. In a square question, it will be 4 into 4 minus 1 by 2. So it will come out to be 3, it will come out to be 6. So here 3 pairs possible, 3 charges, then 3 pairs possible. Here 4 charges means 6 pairs possible. So write down the potential energy of all 3 pairs, write down the potential energy of all 6 pairs in case of a square, okay, or 4 particle system. Sir, how to write potential energy if a charge is placed in external field? So just like, how do you write force? You write force, now if a charge is placed in external field, you write force equal to QE. In the same way, if a charge is placed in external field, then potential energy of the charge, you will write Q into potential at the location of charge. Just like force equal to charge into field at the location of charge, similarly potential energy will be equal to charge into potential at the location of the charge. Who has created that potential? This field has created the potential, because if there is a field, I don't know who has created this field, some source is there. So that source will also create some potential at this point. Just like there is a field at this point, so there will be potential also at this point due to the source charge. Whoever is the source charge, we don't care. Then potential of this charge is given as Q into potential at the location of the charge. Through some example, I will tell you. First of all, solve this. Write potential energy of following system. Equilateral triangle, an equilateral triangle, Q, 2Q, 3Q charges are there. We have to write potential energy. So how many pairs? So we can write 3 pairs. 1, 2, 1, 3, 2, 3. What you will write? 1, 2, it will be K, Q, 2Q by L. K, Q, 2Q by L. Then 1, 3. This one I am saying 1, 2 and 3. 1, 3. So it will be K, Q, 3Q by L plus K, 2Q. 2 plus 3, 5 plus 6, 11 kq square by L. 11 kq square by L. This is how you find potential energy of multiple charge system, more than 2 particle system. ठीक है बच्चा बाड़ी? Now, next question, this one. Write potential energy of this system. There is a ring having charge capital Q. There is a charge minus small q at a distance root 3r. We have to find potential energy of this system. So as I said, we can think like this. The charge Q is located in the field of the ring. Charge minus Q is located in the field of the ring. So how do you write the potential energy of a system? When a charge is located in a field, Q into V, where V will be filled due to ring, V will be potential due to ring at the location of minus Q. So we will write minus Q into potential due to ring at the location of minus Q. This is what I was trying to say that time. Potential due to ring, I told you, KQ divided by under root 3 R square plus R square minus KQQ by 2R. Minus KQQ by 2R. ठीक है बच्चा? Okay. Now, see some question. Sir, whatever you are teaching, is it based on NCERT or not? You may have this doubt, right? So let's go. These are the solved example. If it is visible, then tell me, or we will zoom it more. See this one. Calculate the potential at a point P due to a charge located 9 centimeter away. Located 9 centimeter away. So KQ by small r. KQ by small r. So K will be 9 into 10 power 9. Q will be 4 into 10 power minus 7. 9 into 10 power minus 2. Because centimeter given na bacha. Then we can calculate this, right? It will be 4 into, have they done the calculation? Yes. 4 into 10 power 4 volt. Simple KQ by R formula. Then I am leaving the part B. This question. Two charges, 3 and minus 2, are located 15 centimeter apart. At what point on the line joining the two charges is the electric potential 0? Okay? So let's say we are interested in finding the distance from 3 into 10 power minus 8. Okay? So the first one we will write x equal to 3 into 10 power minus 8 into d. Let's keep it in centimeter, we will get our answer in centimeter only. Divide by Q1 plus Q2 mod only. So 3 plus 2 will be 5. So it gives us 10 power minus 8 cancel, 9 centimeter. x dash, same formula, 3 into 10 power minus 8 into d, q1 minus q2, which is 3 minus 2, which will be 1. It gives us 45 centimeter. Let me remind you, both distances are measured from which charge better? 3 into 10 power minus 8. Both distances I am measuring from 3 into 10 power minus 8 coulomb. Solved example, NCRT, one line answer. I hope you understand this point. That's why the formulas are also important. Okay. Now this question, for the toppers, especially for the toppers. Okay? Those who are fighting for good marks, 150 plus marks in physics. Okay? Focus it. They say that figure 2.8a and b show the field lines of a positive and negative charge. This is field line of a positive charge going away from the charge. This is field line of a negative charge going towards the charge. Okay? They are saying, give the sign of potential difference Vp minus Vq. Vp minus Vq. This is point P, this is point Q, Vp minus Vq. Now, either you can think like this, ki, sir, Kq by R for a positive charge, potential will be positive, and as R is more of Q, since Rp is less than Rq, so Vp will be more than Vq. You can think like this. I don't have any personal problem. But the better way to think is, sir, field is going P to Q, and field always exists from higher potential to lower potential. Field always exists from higher potential to lower potential. That means point P is at higher potential, point Q is at lower potential. It's so simple, right? So Vp is more than Vq. That means Vp minus Vq will be positive. Similarly, apply the same logic here. A and B, they are asking Vb minus Va. They are asking Vb minus Va. So field is existing towards the charge this time. So that means from B to A. So higher potential to lower potential means Vb is more than Va. So Vb minus Va will be also positive. But if you use sir minus Kq by R, then minus sign will confuse you. It will be solved, but it will take some time. So it's better to compare the potential of 2 points, see the direction of the field, if it is provided. Give the sign of potential energy difference of a small negative charge. Sign of potential energy difference of the small negative charge between the points Q and P. Means they are asking UQ minus UP. Okay? And they have put a small negative charge. So either you can use the formula U equal to minus U KQQ by R. But again, same problem. Minus sign is also there, R is also there. You can use this formula or think in the way I'm going to tell you. Bachapadi. Any system tries to decrease its potential energy, we know this fact. Multiple places we have used this fact. Every system wants to decrease its potential energy. Correct? That means anything which is happening on its own, the potential energy must decrease. Any transition which is happening on its own, the potential energy must decrease. Like if you drop a ball, why it doesn't go up, why it goes down? So you can explain the phenomena in terms of force. But also you can explain this phenomena in terms of potential energy. Because when the ball will be dropped, it is going down, because when it will go down, then only the potential energy will decrease. And system wants to decrease the potential energy. So same phenomena we have explained with the help of potential energy, not with the help of force. Similarly, any transition which is happening on its own, naturally, that means the system is trying to decrease the potential energy. Is this point clear? Now understand. This is a positive charge, this is a negative charge. If you leave it, what will happen? If you leave it, what will happen? It will try to attract. There will be attraction, means the distance will decrease. If this means this is happening on its own, I'm not doing anything, I just left it and now I'm seeing it. Now, if the distance is decreasing, that means when they will get close, the potential energy will decrease. So simple. When they will get close, the potential energy will decrease. Okay, bacha body? That means at Q, potential energy is more. And at P, potential energy is less. We don't care about the formula. Okay? So UQ is more than UP, and they're asking UQ minus UP. So I think it will be positive. Similarly, this is a negative charge, and here if you put a negative charge, this time it will try to go away. I know. This time it will try to go away. That means it will try to go from A to B. That means at A, potential energy was more. At B, it is less. That's why it is trying to go from high to low potential energy. UA is more than UB. So UA minus UB will be also positive. Next. Similarly, you can try to think, because if I have told you potential energy, where it is increasing, where it is more, where it is less, then you can conserve mechanical energy, and you can say the same thing about the kinetic energy. Kinetic energy will increase or decrease. It will just do opposite of potential energy. So if potential energy decreased, means kinetic energy will increase, because the mechanical energy must remain conserved. I hope you understand this point, bacha. Can we do this question? This is not for those students who are fighting for 80 marks, 100 marks, for someone who is fighting more than 150. Okay? So I'm trying to cover the entire spectrum of the student. Okay? Chalo, आगे चलते हैं. Come back to the PDF. So like same questions are there. Now try to solve like this one. They're saying find work done. Okay, a charge Q naught. Listen this. A charge Q naught is brought to the center. The four charges being held fixed at its corner. How much extra work is needed to do this? Means this charge was at infinity. Q naught was at infinity. You have brought this here, and these charges are plus Q, minus Q. So how much work will be done in bringing the charge Q naught from infinity to the center? So work done by external force is written as Q delta V, final minus initial, please. And work done by electric force is written as minus Q delta V. Remember it. External force Q delta V minus Q delta V. Okay, so how much extra work is needed? Means they are asking external. Okay? So I will use this formula, and I will say, so first of all we have to find V initial, means when it was at infinity. So obviously it is 0. Potential at infinity we will take 0. What is potential final at the center due to the four charges? So I already told you, come on, NCRT, right? I already told you K by R into sigma Q. How much is sigma Q? How much is the Q total? Plus Q minus Q, 0. Minus Q plus Q, 0. The answer is here, 0. That means therefore the work done, both are 0, so work done will be 0. There will be no work done in bringing the charge Q naught from infinity to the center, because these charges are not producing any potential at the center. I hope you understand these. Okay. Coming to the electrostatics of conductor, there are some points which is written in the NCRT. If you want, I can show you. I don't want to waste time. Okay? 5-6 points are there. Please take care of that. First, net electric field inside conductor is 0, because we have to maintain the electrostatic nature of the conductor. Electrostatic means the free electrons must be at rest. The free electrons must be at rest. So if you apply any electric field inside the conductor, that electric field will make the free electrons move. And if the free electrons start moving, that becomes a question of current electricity, the next to next chapter, right? So we are talking about electrostatic of conductor. The free electrons are not supposed to move. So that means there must not be any electric field, because electric field make the free electrons move and the electrostatic nature will be destroyed. So under electrostatic condition, net electric field inside the conductor should be 0. Similarly, there will be no excess charge. There will be charge. There will be free electrons. There will be protons inside the bulk. But if you give some extra charge, that extra charge will never be inside the bulk. It will be always on the surface of the conductor. Now, since field is 0, then entire conductor is equipotential. Entire conductor is equipotential. One more point regarding this charge density. At sharp edge, the sigma will be high. Like this is a sharp edge. Here sigma will be high, but this one is flat zone. So here sigma will be less. Means charges will be crowded at the sharp edge and they will be far away from each other and on flat surface. And field inside is zero, but just outside or outside there will be field. So field inside the conductor is zero. Outside there is always some field. Right? How much field near the surface? Near the surface, the field is always sigma by epsilon naught. Near the surface, the field is always sigma by epsilon naught. Now they use the term electrostatic shielding. What is electrostatic shielding? If there is a conductor with a cavity, this we are calling cavity, and there is no charge inside the cavity. If you place no charge inside the cavity, but there is electric field outside. There is electric field outside. What will happen? This electric field will force the free electrons on the opposite side. Means there will be excess of electrons on the opposite side, and there will be deficiency of electron. We call these charges as induced charges. Now this induced charge will produce its own electric field, E induced, in opposite direction of the existing field, and the net field inside the conductor will be zero everywhere. In the bulk it will be zero, as well as in the cavity also it will be zero. So it will be zero everywhere. It will be zero everywhere. Okay? That means if you want to save any device which is quite sensitive device, if you place it in an electric field, it will be destroyed. So if you want to save a device from external electric field, you can put it inside a cavity of a conductor. Because conductor will make sure that inside it there is no electric field. Even if there is outside electric field, there is no electric field inside. Conductor will make sure. Conductor knows the physics, right? Then that device is saved. Now that means conductor has shielded the device from the outside electric field. That's why we call it electrostatic shielding. Whatever be the charge and field configuration outside, whatever is the field outside, any cavity in a conductor remains shielded from outside electric field. The field inside the cavity is always zero. Always means only in that case when charge inside cavity is zero, then only you can claim field inside cavity is zero. If there is some charge inside cavity, then there will be field inside cavity also. So they are talking always, that means they are saying there is no charge inside the cavity. Charge is only present outside the cavity. Charge is present here, no problem. Okay? This is known as electrostatic shielding. Come to the next case. Come to the next case. Potential due to dipole. Potential due to dipole, formula if you remember, Kp cos theta by r square. Kp cos theta by r square. And we also write it like this, P vector dot r cap by r square. At axial point potential is written as, because axial point means theta is 0 as well as 180 degrees, so it is written as cos 0 is 1 and cos 180 is -1. Okay? So potential at the axial point is written as plus minus Kp by r square. Now I will say one important point here, please listen. Generally we say that potential at axial point of a dipole is maximum. No, it is not maximum. Maximum means you are talking only theta equal to 0 degree. It is minimum also. At theta equal to 180, it is plus minus Kp by r square. But generally students think only Kp by r square. So don't say that potential at axial point is maximum. It is both maximum and minimum. Please take care of this thing. Okay, bacha? Okay, now we know this formula. If you place a dipole in a uniform electric field, then net force is 0. Because one force will act in the direction of field, another force will act opposite direction of the field. Okay? Torque is P cross E, P cross E, P cross E, like this, inward. Or you can remember like this, electric field always wants to align P vector along its own direction. Means electric field always want P vector to be parallel to itself. Means theta equal to 0 degree. Electric field always wants theta equal to 0 degree. See, it always wants to align the dipole like this. So understand na yaar, one dipole at some angle. Now it will be horizontal. So in which direction it is rotating? Clockwise. That means what is the direction of the torque? Clockwise. Okay? So instead of doing P cross E, you can simply think in which direction the dipole will be rotated by the electric field. That is the direction of the torque. Now force is always 0. That means dipole will be always in translational equilibrium. AKD sir told translational equilibrium, right? So force is 0. That means dipole will be always in translational equilibrium. But if torque is 0, then it will be in rotational equilibrium also. And complete equilibrium you are allowed to say when both translational and rotational equilibrium exist. And it will exist when sine theta will be 0. That means for theta equal to 0 and 180 degree, 0 degree is known as stable, and this one is known as 1 stable. That's why dipole always wants to go theta equal to 0. Okay? Then potential energy of the system is written as minus P dot E minus P cos theta. At theta equal to 0, due to the negative sign, potential energy will be minimum, which is minus P, theta 180, maximum plus P, that's why 0 degree. Minimum potential energy is known as stable. Minimum potential energy configuration is known as stable equilibrium. Maximum potential energy will be known as unstable equilibrium. They will say, find work done, external work done in rotating the dipole from angle theta 1 to theta 2. From angle theta 1 to theta 2 equal to delta U, which will be P cos theta 1 minus theta 2. Actually, this is 2 minus 1. But since there is a negative sign, so it is appearing 1 minus 2. But we have done final minus initial only. Don't worry. Okay? Then time period of a small oscillation. If you disturb the dipole, then it will oscillate like this. So time period of a small oscillation will be 2 pi under root I by P. What is I? I is moment of inertia of dipole. ठीक है बच्चा वाड़ी? Coming to the capacitor, the first formula we should remember. What is the capacitance of isolated spherical capacitor? So it is 4 pi epsilon naught R, or you can say R by K, Coulomb's constant. Okay? Now they ask this question, if you remember, n identical drops, they merge. Then what happens? Then in fluid mechanics you might have done it, volume conservation. Radius will become n into n power 1 by 3 into smaller. The one single, this is smaller drop, it combined with so many smaller drops, identical smaller drops, and then it becomes one single drop. This is capital R, and here it is smaller. So capital R is nothing but n power 1 by 3 smaller. And capacitance, since it is proportional to radius only, so it will also become n power 1 by 3 R. They will say here the potential was V, and here it is V dash. So remember V dash equal to n to the power 2 by 3 V. V dash is n to the power 2 by 3 V. Next. A spherical capacitor, when outer cell is earthed. So spherical capacitor means there are two spheres. One is inside, one is outside. Inside radius A, outside radius B. A spherical capacitor outside this one is earthed. Then formula is 4 pi epsilon naught AB upon B minus A. A is smaller radius, B is larger radius. Then this is the important parallel plate capacitor. Parallel plate capacitor. Battery will be connected here. This area we say A. You know the formula, na? You know the formula. Epsilon naught A by D. A is this area. Generally we draw like that. So this A is invisible here because you are trying to draw in 2D. But in 3D when you visualize, I hope you understand what is the meaning of area A. Sometimes they will say a capacitor is having circular plates. Circular plates. That means area you will take pi r square. This is the distance between the plates of capacitor. The capacitance formula is epsilon naught A by D. Then we know Q equal to CV. The main formula we know Q equal to CV. What is the field inside capacitor? Field inside capacitor is sigma by epsilon naught, because This one will produce, one plate will produce sigma by 2 epsilon naught. Another plate will also produce the same sigma by 2 epsilon naught. So total will be sigma by 2 epsilon naught plus sigma by 2 epsilon naught equal to sigma by epsilon naught. Positive plate sigma by 2 epsilon, negative plate sigma by 2 epsilon naught in the same direction. So total will be sigma by epsilon naught. Or you can write Q by A epsilon naught. Then potential difference you can write QD by A epsilon naught. Then they ask force between plates of capacitor. Now when you are writing force, you have to understand. If you are writing force on the, let's say, negative plate, if you are writing force on the negative plate, then you can't take the net field. Here a student do mistake. You can't take the net field because net field include the field due to positive as well as negative. But if you are finding force on the negative plate, why you will consider the field of the negative plate? Do you think the field of the negative plate will apply force on the negative plate? No. A field due to a charge never applies force on the same charge. Field due to a charge never applies force on the source charge on itself. Clear? So that means when you are finding force on the negative plate, you must consider the field due to positive plate only. That's why instead of taking Q by A epsilon naught, I will take half of that, Q by 2A epsilon naught. And the force formula will be Q square by 2 epsilon naught, or when you do some changes, it comes out to be CV square by 2D. Now, which formula we will apply? It will depend on what is given in the question. Coming to the combination of capacitor. The first one is series combination. Series combination, that means there should not be any branching between the capacitor, means no capacitor should be connected like this. If some capacitor is connected, that means this is branching over here. There must not be any branching. Then charge on the plate of the capacitor will remain same. This is having Q, then this will also have Q. The charge on the plate of the capacitor will be same. Then vacha body. Important formula. 1 by CS equal to 1 by C1 plus 1 by C2. In parallel combination, CP equal to C1 plus C2, we already know. We already know this thing. Chalo, let's solve this question. VM minus VB is 12 volt, means you can think there is a battery connected. There is a battery connected of 12 volt. You can think like this. They are asking find charge and voltage across each capacitor. Every capacitor I want to find charge and voltage. So we will use some basic property like in series combination, charge on individual as well as equivalent are equal. In parallel, potential across individual and equivalent are also equal. So that means 4 and 2 parallel. So we can transform this one into 4 plus 2, 6, and this one is 3. And here it is 12 volt. And then 3 and 6, if you calculate, you will get 2. So, and 12 volt. So what is the charge here? The charge we got, CV, C is C equivalent. C is 2 into 12, 24 microcoulomb. But 24 is on the equivalent. 24 is on the equivalent. Now come here. Come back. In series combination, 2 microfarad is series combination of 3 and 6. In series combination, the equivalent and the individual have same charge. That means 3 microfarad also has 24, and this one will also have 24. Once you know the charge and capacitance, you can use Q equal to CV and find the potential. So 24 by 3, 8 volt, 24 by 6, 4 volt. And you can see 8 plus 4 was 12. That means in series, the potential will be divided. Charge will be same, potential will be divided. Now, so we know the result here, 24 and 8. Come here. Here 24, these are the parallel combination, and potential is 4 volt. So equivalent has 4 volt, then individual will also have 4 volt and 4 volt. Once you know the potential and the capacitance, you can know the Q equal to CV, 4 into 4, 16. And here, 2 into 4, 8. So you can see 16 plus 8, 24. So in parallel, charge is divided, what potential remains same. In series, charge remains same and potential is divided. बचा बड़ी. If you fill a capacitor completely with dielectric, first of all, what happens when you keep a dielectric in an electric field E naught? If you keep a dielectric in electric field E naught, just like conductor, I told you, some induced charges are there. In dielectric also, induced charges will develop, just like conductor, है ना? But there is a difference. Conductor also produces an induced opposite direction. But in conductor, this E induced is always equal to E naught. And that's why in the conductor, we say net field is 0. I told you, just told you, है ना? कि net field inside conductor becomes 0 because of the cancellation of the field by induced charges. Here also induced charge is trying to do the same thing. First of all, what is the meaning of dielectric? Dielectric means insulator. So insulator is also trying to do the same thing, but since it doesn't have free electrons, so the method is different. I can't tell you the method right now. Method is different. These are not free electrons. But somehow it has developed. It is trying to copy the conductor, but not able to do it. But somewhat it has achieved. What it has achieved? The induced field it is able to produce in the opposite direction of the existing field, due to which the net field is reduced. The net field E is less than E naught. How much? E naught by K. The K is known as dielectric constant. The K is known as dielectric constant. I hope you understand this point. Then, when you fill a capacitor completely with a dielectric, completely filled, then capacitance becomes K times. We know this fact. Capacitance becomes K times. But what will happen, sir, if I fill a capacitor partially with a dielectric? Partially, the distance between the plate is D, but the dielectric thickness is T. Then the formula goes like epsilon naught A divided by D minus T plus T by K. Very important. Epsilon naught A divided by T minus T plus K. Let's solve a question. Give your answer. Come on. Direct formula based. Air filled capacitance is given. Thickness of dielectric is 3D by 4, where D is the distance between the plate, means it is less, means it is a partial filled case. Dielectric constant is 3. Find new capacitance. Come on. बोला भाई, give your answer. Give me a loud answer, bhai. The voice should reach in the studio room. Doesn't matter wherever you are. Are you getting any answer? Let's find the capacitance. Using this formula, epsilon naught A divided by D minus T. How much is T? 3D by 4 plus 3D by 4 by K. How much is K, beta? 3. So it will become epsilon naught A divided by D minus D by 4, and this one is D by 4. It will become D by 4 plus D by 4, D by 2. It will become 2 epsilon naught A by D. That is 2 C naught. C naught was 2, it will become 4 microfarad. Epsilon naught A by D was nothing but 2 microfarad given. So answer will be 2 times of 2, which is 4 microfarad. Next, this, if you fill 2 dielectrics like these two, this we call series combination of dielectric, and this one we call parallel combination of dielectric. Now, I want to replace 2 dielectric with only one dielectric. Okay? Then we have to decide. I can't put K1 or K2. We have to decide something. So how much it will be? So it will be somewhere between K1 and K2. It will be kind of an average. It will kind of an average. So what is the formula? In series, the formula is, if the thickness is T1 and T2, the formula goes like T1 plus T2 divided by K equivalent equal to T1 by K1 plus T2 by K2. And in parallel, area, let's say A1 and A2, that will become K1 A1 plus K2 A2 divided by K1 plus K2. Both are average, kind of average. So always remember K equivalent must lie between K1 and K2. You can check the options sometimes, no need to solve it. If they are identical, in case of identical, T1 plus T2 will become 2T and TT will get cancelled. 2 by K equivalent equal to 1 by K1 plus 1 by K2. If 3 are there, then 3 by K equivalent, and then one more term 1 by K3. 5 are there, 5 by K equivalent, 3 more terms. Here A and this one, A will take common, and sorry, this one I have written wrong. It should be A1 plus A2. My mistake. It should be A1 plus A2. So A common, this one will become 2A. A will get cancel out and we will get K1 plus K2 by 2. If there are 3, then K1 plus K2 plus K3 by 3. And so on. Now, very, very, very important question. Please make the change here. If you get the notes, then make the change here. It will be A1 plus A2, please. A1 plus A2, this one, not K1 plus K2, A1 plus A2, okay? Dielectric inserted inside capacitor. They will say here capacitor is charged with the help of a battery. It is charged. Now we are trying to insert a dielectric here of constant K, but in 2 ways. First, the battery remains connected. Second case, the battery is removed. So while battery remains connected, in both cases, capacitance will become K times. Both case capacitance will become K times. Battery remains connected case, potential will remain constant. Here charge will remain constant. Why potential will remain constant? Because it is the job of the battery to keep the potential constant. The job of the battery to keep the potential constant. And here charge will remain constant because once you remove the battery, then charge cannot flow from one plate to another plate. The charges are trapped. The charges are trapped. It cannot go from one plate to another plate. So here charge remains constant, battery remains connected, potential remains constant, then all formula like Q equal to CV. V is constant, but C becomes K times. So this will also become K times, means increases. It increases. But electric field is V by D. V is constant, D is constant. So electric field will also remain constant. Means whatever happened to potential, the same thing will happen to electric field. Energy, we will use the formula because V is constant. So I will better use the formula CV square. V is constant, C becomes K times. So this one also become K times. Similarly, you can check out this one also. So here increasing, increasing. Here V naught by K, decreasing, decreasing, decreasing. The next very important concept is the concept of common potential. See here. Again, capacitor is charged by battery. Another capacitor charged by battery. V1, V2. Charge is Q1, Q2. Now they will say their plates are connected together in 2 ways. Positive connected with positive, negative with negative. We call it same plates connected together. Then positive will be connected with negative. Q1 will be connected with minus Q2. And minus Q1 will be connected with plus Q2. Then we will say opposite plates connected together. So when you connect the plates together, something like this, then the potential difference, the wire will make sure the potential difference become equal. Right now they are having different potential, V1 and V2. But after making the connection, the potential difference must be equally across both capacitor. That's why the name is common potential. If finally the potential will be same, the common. And how much it will be? So it will be C1V1 plus C2V2 divided by C1 plus C2. C1V1 is nothing but Q1. Sometimes they will give you charge, so you can directly find Q1 plus Q2 divided by C1 plus C2. Okay? Then in this process, obviously, what I told you, if something is happening on its own spontaneously, I'm not doing anything, I'm just making the connection. The system is doing this reconfiguration. That means the potential energy of the system must decrease. That is a universal law, right? So if potential energy means electrical energy of the system will decrease, then remaining will be seen as loss in whatever form, in EM waves, whatever form, it will be seen as a loss of energy, how much? Remember the formula, half C1 C2 divided by C1 plus C2 into V1 minus V2 whole square. But if you connect the opposite plates, then this plus will become here minus, and this minus will become here plus. That is the only difference when opposite plates are connected together. In NCERT, there's a question based on this. NEET has asked multiple times question based on this. Please take care. You want to check which question? See, that 3D by 4 wala question we have done. Hai it's not like that ki I'm going away from NCERT, I'm discussing NCERT only, bachawadi, but in a different way. This one is series parallel combination. Do it after the class, do it. Now this is the question I was talking. 900 picofarad capacitor is charged by 100 volt battery. How much energy is stored by the capacitor? First of all, they are saying how much energy is stored. So initial energy, how much is stored? So it is half CVS square. It will be half into 900 picofarad means 10 to the minus 12 into 100 square. Whatever is the answer, I don't care. The capacitor is disconnected from the battery and connected to another 900 picofarad capacitor. What is the energy stored by the system? That means ki it is connected to the other which is uncharged. So this one is, it was having some 100 volt. It was having 100 volt, and this one was having earlier 0 volt. What will happen final? The final, the common potential will be C1 V1, which is 900 into 10 to the power minus 12 into 100 divided by C1 plus C2, which is 900 into 1800 into 10 to the power minus 12. We will get 50 volt. Once you get the potential 50 volt, that is both now having 50 and 50, because data is symmetric, capacitances are equal, and one was uncharged. Then final energy will be half C V dash square. Let's call it V dash, half C V dash square into 2. Half C V dash square into 2. Kar lenge? So that's why I was saying that these questions are already there. Now coming to the next chapter, which is current electricity. What are the important formula you have to remember in current electricity? First of all, the formula of drift speed. Drift speed formula is E by m into tau. E is electronic charge, the charge of the electron. M is the mass of the electron. E is the electric field applied by the battery, and T is known as relaxation time. Then what is the relation between current and VD? I equal to NEA VD. Then we define a term current density, which is current by area, which will become, if you divide with area, it will become NEVD. You will find these things in your notes, right? Just I have accumulated everything here. And then we define a term mobility, which is VD by E. So VD by E, VD by electric field, so it will become E tau by M. Now, on increasing the temperature, tau decreases. Remember this point, when you increase the temperature, the collisions happen, the thermal speed increases, collision happens very fast, and that's why the relaxation time decreases. The time between successive collision decreases. Now another important formulas are J equal to sigma E, we call it point form of Ohm's law, microscopic form of Ohm's law. J equal to sigma E, or E we can write rho J. E we can write rho J. Where sigma and rho has this relation, sigma equal to 1 by rho. Sigma is known as electrical conductivity, and reciprocal we call resistivity. Conductivity and resistivity. Bajabadi. So, if I increase the temperature, what will happen here? Understand, NCERT has talked about this. If you increase the temperature, then tau will decrease, and N will almost remain constant. Remember this point, very important, theoretical point. On increasing the temperature, tau decreases, but N almost remain constant. That's why resistivity increases with temperature, and its relation is given as rho equal to rho naught 1 plus alpha delta T, the famous relation I hope you know. That means on increasing the temperature, resistivity increases. But understand why? Because tau decreases and N almost remain constant. Because the free electrons are already free. When you increase the temperature, their number will not increase by that much amount. It is not a semiconductor. It will go from conduction balanced band to conduction band. Free electrons of a metal are already in conduction band, and even at room temperature. I hope you understand this. So even if you increase the temperature, nothing appreciable amount of change is going to happen. But if it is a semiconductor, remember, if it is a semiconductor, reverse happen. In semiconductor, this almost remain constant, and N increases. When N increases, that's why resistivity decreases on increasing the temperature in semiconductor. I hope you remember the point. Okay? So entire thing lies here. We will see numerical based on this. Don't worry. Rho equal to rho naught 1 plus alpha delta T. We will see the numerical. Now Ohm's law. Ohm's law is delta V equal to IR. Delta V is proportional to I at constant temperature, where R is known as resistance, which is rho L by A. Now this question is very important. If you stretch a wire, that means in any question where volume is constant, instead of stretching the wire, they will say it has been melted and transformed into new wire. Anything like this, where volume is constant. Then don't say R is proportional to L. Here you may get an idea R proportional to L, R inversely proportional to A. No, you can say R proportional to A when you are saying A is constant. You can say this thing when you are saying L is constant. But in this question, A and L are not constant. Volume is constant. So when volume is constant, we will do some changes. It is there in your notes. R is proportional to L square, inversely proportional to A square, not L and A, and inversely proportional to the diameter or radius to the power 4. For small changes, single digit, 2%, 3%, 4%. Delta R by R is 2 times. Here also minus 2 times means if area is increasing, resistance will decrease. This is the meaning of minus sign. And here minus 4 times delta D by D. Very important, you know this thing. They have asked, and they will keep on ask this thing. Okay, bacha? This one we know. Series combination, parallel combination we know. No need to discuss. Now we will solve the question. Power formula also we know. Power dissipated in a resistor is I square R, V square by R, or I into V. What is I and V? Just let me tell you. If this is a resistor, I is the current, R is resistance, and V is not the EMF of the battery. Generally, a student do this mistake. V they take EMF of the battery. No, V is the potential difference across the resistor through which you are finding the power. Okay, bachawadi? Now this is a question. 8 ohm, 4 ohm, 6 ohm connected like this to a 10 volt, internal resistance 1 ohm. Internal resistance 1 ohm. And they are saying find current, voltage, power dissipated through each resistor. Come on. चलो भाई सॉल्व करते हैं. To find voltage, current, everything, you need to keep on solving the circuit. Like 8 and 4, it will become series, so it will become 12 ohm, and then 6 ohm, right? And then it will be connected to this 1 ohm. 12 and 6, they are in parallel, so R equivalent will be 12 into 6 divided by 18, which is 4 ohm. So you will write like this, 4 ohm Now 4 ohm and 1 ohm, they are in parallel. So current in the circuit will be 10 volt divided by 5 ohm. 4 ohm and 1 ohm are in series. Sorry, 4 ohm and 1 ohm are in series. So total will be 5 ohm. So current will become 2 ampere. But what is this current? When you do EMF of the battery divided by R equivalent, do you get which current? The current passing through the battery. Remember it. When you divide EMF with R equivalent, you get the current passing through the battery. That means what we have got here is this current. That means 1 ohm will have the same current because it is in series with the battery. So we have got here 2 ampere. Once you got the 2 ampere, you can, when you know two data, then you can find the third one using V equal to IR, right? So I know here R and I, so V equal to IR, so here it will be 2 volt. Here it will be 2 volt. So if it is 2 volt and this one is 10 volt, then in series, this one should be 8 volt, understand? This one should be 8 volt. Now if it is 8 volt, but 4 was nothing but the parallel of 12 and 6. And in parallel combination, the equivalent and the individual both have the same voltage. So if the equivalent is having 8 volt, then individual also must have 8 volt and 8 volt. That gives us a current. That gives us a current V by R. Because two data we know. 8 by 6. 8 by 6. And 8 by 12. So I think it will be 2 by 3. Correct. 4 by 3 plus 2 by 3 will be 6 by 3, which is 2 ampere. Current was 2 ampere. It is correct. Now, once you know the 2 by 3, so that means here also current will be 2 by 3 because in series 12 is nothing but the series combination of 8 and 4. So whatever current in going in equivalent, the same 2 by 3 will go here as well as here, 2 by 3. Now once you know 2 by 3, you know the voltage IR, 16 by 3 volt. And here 8 by 3 volt. All the current and voltage we know. Once you know all the current and voltage, you can find power. Like power dissipated in 8 ohm, we can write either I square R or V square by R, whatever you prefer. So I square into R. Through 4, same. I square into R. Then 6 ohm. 6 ohm had a current of 4 by 3. Or voltage. Voltage it had 8. Anyways, 4 by 3 whole square into 6. And P1. It was 2 square into 1. Whatever is the answer. Now, instead of giving the resistor, they may give you the bulb. 4 bulbs are given, 8 ohm, 4 ohm, 6 ohm, 1 ohm. 4 bulbs are there. And they will ask you which bulb will glow brightest. Then you find the power like this. It will become a lengthy question. You find a power like this and then see which power is maximum. The maximum power means that bulb will glow brightest. That bulb will glow brightest. Which bulb glow brightest? The one which is dissipating highest power. Don't see the current, don't see the voltage, see the power. Okay? Next. Potential difference across the battery. Potential difference across the battery. If it is ideal battery, then potential difference is equal to EMF. Potential difference is equal to EMF. But if it is real battery, then two cases, discharging of battery and charging of battery. Discharging of battery means current is coming out of the positive terminal, means normal functioning of the battery. Generally, battery gives current from the positive terminal. That battery is discharging. But in some cases, you may find the current going inside the battery, inside the positive terminal of the battery. We call it charging of battery, and here potential difference we write. Potential difference means better. If you take these 2 points, A and B, these 2 points, A and B. A is connected to positive terminal. That means A is at higher potential as compared to B, but not by amount E. A is higher as compared to B, but not by amount E. Rather by how much? E minus IR. So VA minus VB is E minus IR, and here VA minus VB is E plus IR. But in case of ideal battery, no internal resistance. In case of ideal battery, if you take VA and VB, then VA minus VB is E only. The A is at high potential in all three cases, but by different amount. A is at higher potential as compared to B, but here by amount E, here by amount E minus IR, A is more than B. Here A is more than B by amount E plus IR. Combination of cell, series combination. If there is no branching, they are connected like this, no branching, then E equivalent is written as E1 plus E2 plus E3, so on. If they are opposite connected, wrongly connected means, see, if you look at the individual battery, it is trying to give the current clockwise. E2 is also trying to give the current clockwise. All the cells are trying to give the current clockwise. That means they are rightly connected. But sometimes, some will give current clockwise, some will give current anti-clockwise. In that case, you have to take negative also. But R equivalent in every case, it will be plus only. R1 plus R2. Whether rightly connected or wrongly connected, it will be plus only. And finally, you will replace this circuit with something like this. E, R equivalent, capital R. So now finally here the load resistance current, you will write E equivalent divided by R equivalent, which is capital R plus small r equivalent. Capital R plus small r equivalent. In the parallel combination, in parallel combination of cell, you can see the left and right side are connected together. So first of all we find R equivalent, the equivalent internal resistance, which is 1 by R equivalent equal to 1 by R1 plus 1 by R2 and so on. Then we will use E equivalent by R equivalent, which is E1 by R1 plus E2 by R2 and so on. Understand here? In series, you can find E equivalent and R equivalent separately. But here, if you want to find in parallel, if you want to find E equivalent, you must find R equivalent first. Because once you find R equivalent, then only you can multiply this side and you will get the E equivalent thing. Okay, bachawadi? One thing remember, E equivalent in parallel is a kind of average, not in series, this one. Here, E equivalent which we will get, it is kind of an average. Means it will be lying between the minimum and the maximum EMF. It will be lying between minimum and maximum EMF. Remember the point? And remember for identical cells in parallel, E equivalent will be equal to E and R equivalent will be R by N. E equivalent will be E, R equivalent will be R by N. Now coming to Wheatstone bridge. We will see question based on cell. Wheatstone bridge. You know this, R1, R2, R3, R4. For balanced condition, R1 by R3 and R3 by R4 should be equal. Then you can remove the R5. When you remove the R5, then R1, R3 are in series, R2 and R4 are in series. R1 and R3 are in series, R2 and R4 are in series, then we can solve. Like the question here. Check beta, 8 by 2 and 16 by 4. So this ratio is 4, this ratio is also 4. That means this is a balanced Wheatstone bridge. Okay? So balanced Wheatstone bridge, that means we can remove 10 ohm. Once you remove 10 ohm, the circuit will look like this. Beta. Eight, 16 in series, 2 and 4 in series. So it will become 24 and 6. They will be in parallel. So R equivalent we will write 24 into 6 divided by 24 plus 6, which will become 24 by 5 ohm. 24 by 5 ohm. What about this one? Don't say this is now Wheatstone bridge. Can we say this is a Wheatstone bridge? No. Hana? In Wheatstone bridge, the terminals are connected to only 4 resistors. Listen, in Wheatstone bridge, the terminal A and B, they will be connected to only 4 resistors. Wheatstone bridge has 5 resistors. Hana? Out of 5, terminals will be connected to the 4 in pairs. Like A is connected to 8 and 2. B is connected to 16 and 4. No terminal is connected to the 10. This is how we identify the 5th resistor. The 5th resistors in some complex diagram, you don't understand, sir, which one to remove. You should remove that one which is not connected to any, or which is the 5th resistor. The 5th resistor is the resistor which is not connected to any terminal. Then where is the 5th resistor connected? To the same 4. To the same 4. Like 10 ohm. 10 ohm is connected to 8 and 16 on the upper side, and 10 ohm is connected to 2 and 4 on the lower side. 8 and 16 on the upper side, 2 and 4 on the lower side. But if you check here, terminal is connected to 8 and 2 and 12, all 3. Terminal is connected to 8 and 2 and 12, all 3. This is not a Wheatstone. Before going to Wheatstone, you should first check series and parallel. You can see there is no branching between 8 and 16. These two are in series. Come on. These two are in series. So equivalent circuit will look like this. 24, 6 ohm, 12 ohm. They are all in parallel. So you will apply 1 by R equivalent. You will have 1 by 24 plus 1 by 12 plus 1 by 6. But generally students think, yeah, this is a Wheatstone. No. First of all, we should, whenever you get any circuit, we should always look out for series parallel first. When you don't find any series, any parallel, then only you should look out for Wheatstone. Directly don't jump for Wheatstone. If it is obvious, then okay. But always cross-check. For the cube register, although NEET has never asked this, but in NCRT, they have given one solved example where they are asking about current and all. Just remember the result in case if they ask R equivalent, just remember the result. About edge. Edge means if the battery is connected between A and C, this is edge. Then R equivalent is 7R by 12, where R is the resistor of each edge, each side. If it is phase diagonal, what is phase diagonal better? Between A and D, means battery is connected between A and D, these 2 points, A and D. Then the R equivalent will be 3R by 4. And if it is body diagonal, between one lower corner and the back side upper corner, and here the battery is connected, then it is 5R by 6. Please remember the result directly. In case, if they ask, you should be able to know. Okay, although very less chance. Coming to the meter bridge. Coming to the meter bridge. It is used to find unknown resistance. It is used to find unknown resistance. Where R is known resistance. Then there is a slider or jockey, you can say. This is L1, this one is L2. L2 is nothing but 100 minus L1 centimeter. Because this is a meter bridge, meter scale, 1 meter length, 100 centimeter length. Now, this is based on Wheatstone bridge. When you find no deflection at null point, no deflection in the galvanometer, X by R1 will be equal to R by R2, but R1 and R2 ratio will be proportional to L1 and L2 ratio. So we have written X by R equal to L1 by L2. You can write L1 divided by 100 minus L1. L1 will be given in the question, R will be given in the question because R is known. You can find X. X will be R into L1 divided by 100 minus L1. R into L1 divided by 100 minus L1. Okay, bacha body. Chalo, let's see some question. Question number 3.1. The storage battery of a car has EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, what is the maximum current that can be drawn from the battery? Understand? There's a battery, and they're asking what maximum current we can draw from the battery. E is given, a small r is given. What maximum current we can draw from the battery? Now, to draw the current from the battery, you must connect the terminal. But when you connect the terminal, there will be a load resistance R. There will be a load resistance R. But you can change it, because they're asking maximum current. That means we can change this capital R. So I, we will write E upon R plus a small r. E upon R plus small r. But since a small, I want maximum current, so I will short circuit. I want maximum current, so I will short circuit, means I will put capital R equal to 0. That means I will short circuit the battery. Okay? So because you can't change the small r, it is given 0.4 ohm. You can't change E, only capital R you can change. So for maximum I, capital R has to be minimum, which is 0. So I max will become E by small r. So 12 by 0.4, 30 ampere. Next question, 3.2, come on. 3.2. Correct, beta, correct. Battery of EMF 10 volt and internal resistance 3 ohm is connected to resistor. If the current in the circuit is 0.5 ampere, okay. This is 10 volt, internal resistance 3 ohm, and the current we are finding here is 0.5 ampere. They're asking what is the resistance. What is resistance? No problem. 0.5 equal to E divided by R plus smaller. If you take 1 by 2, 20, then R plus 3 will be 20, then R equal to 17 ohm. R equal to 17 ohm. Come on. Here come. What is the terminal voltage of the battery? Tell me, this is a charging case or discharging case? Obviously, one battery is there, current is coming out of the positive. So this is a charging case. So potential difference, terminal voltage, potential difference, I will write E minus IR. E is how much? 10. I we got 0.5 given already. And R, the internal resistance given 3. So 10 minus 3, 1.5 will be, terminal voltage is 8.5 volt. Terminal voltage is 8.5 volt. Good. It is 8.5 volt. So that's why terminal voltage concept is important. They can ask you. Next. At room temperature, 27 degrees Celsius, resistance of an element is 100 ohm. Okay, 27 degrees Celsius, something is 100 ohm. Now, what is the temperature of the element if the resistance is found to be 117 ohm? What will be this temperature? Okay, temperature coefficient given. So what we will apply? We will apply R equal to R naught 1 plus alpha delta T, or you can write delta R by R naught, just like thermal expansion formula, if you remember. Delta R by R naught equal to alpha delta T. Delta R 117 minus 100. Come on, 117 minus 100 divided by R naught. Initial, R naught is initial, which is 100, equal to alpha 1.7 into 10 power minus 4 into delta T. So this will come out to be 17. The delta T will be 17 by 100. Okay, we can 17 by 100 means we can write 0.17 divided by 1.7 into 10 power minus 4 equal to what 1000 we are getting. Check the calculation. Delta T is 1000. So if it is 1000, then final answer will be, final temperature change is 1000, so final will be 1027. Final temperature will be 1027 because the change is 1000. Don't say the answer is 1000. Answer is delta T change, so it will be 1027. Similarly, 3.5. Come on, go for 3.5. This 3.4 is nothing but rho L by A. Go for 3.5. Come on, Vacha. A silver wire has a resistance of 2.1 ohm at 27.5 degrees Celsius and 2.7. So we will write delta R by R equal to alpha delta T. So delta will be 2.7 minus 2.1 divided by initial, which is 2.1, equal to alpha delta T. I will write 100 minus 27.5. 100 minus 27.5. We will solve this and we will find alpha. Okay. Okay. So these are some questions of NCERT. Coming to the next chapter, which is moving charges and magnetism. So first we will start with magnetic field. The Biot-Savart law. It gives magnetic field due to a current carrying element. It gives magnetic field due to current carrying element. If there is a small element, ideal, and you want to find magnetic field at point P, then first we have to draw R vector, and R vector is always drawn from ideal vector to P. R vector is always drawn from ideal vector to P. So one we have ideal vector, one we have R vector, angle between them is theta. Then in vector form we write mu naught by 4 pi ideal cross R by RQ. Or magnitude I will write ideal cross R, I will write ideal into R into sine theta. Ideal into R into sine theta. Then RQ, R and RQ will cancel, it will be 1 by R square. We can extend this to moving charge also. Instead of taking ideal, I will take a charge Q, point charge Q, which is moving with velocity V in the upward direction. Both are similar case. Only thing you have to change is you replace ideal with QV vector. Okay. So QV vector is there, R vector is there. Then we will write mu naught by 4 pi Q V cross R by RQ. What I have done, I have replaced ideal with QV vector. Come on. Now see, magnetic field due to ring. At the center we know the formula mu naught I by 2R. At the center we know the formula mu naught I by 2R, but if there are n turns, we need to multiply with n. But at an axial point at a distance x, the formula is mu naught n I R square divided by 2R square plus x square, 3 by 2. What is magnetic field due to arc? At the center, it is mu naught I by 2R, whatever we got here, mu naught I by 2R. But this field was due to 2 pi, total 2 pi. But here it is subtending an angle theta. So we need to multiply the fraction theta by total, which is 2 pi. Because this is the field due to the entire ring. So field due to entire ring into theta by 2 pi. Like if it is semicircle, then theta I will put pi in radian, which will become half. Because its contribution will be half. Quarter ring, that means pi by 2. So it will become 1 by 4. Like that. Whatever angle given, 60 degree given, don't put 60 degree. If you are putting 60 degree, you take it 360 degree. If you are writing 2 pi, then you write 60 degree as pi by 3. So pi by 3 divided by 2 pi, it will become 1 by 6. Now field due to finite wire. Due to finite wire, at this point, you have to draw two important lines. First, draw perpendicular. Like at this point P, we are interested in finding field due to a finite wire having current I. So draw perpendicular from point P on the wire. First line, draw perpendicular from the point P on the wire. Let's call that distance as D. Let's call the distance as D. First line, draw perpendicular from point P on the wire. Then join the ends. From point P, join the ends. From point P, join the ends. You will get two angle between this first line, which I said, and line joining the end, alpha and beta. Then magnetic field at this point P is written as mu naught I by 4 pi d sine alpha plus sine beta. Direction wise the same, just like infinite wire. Thumb will be in the direction of current. Open the fingers towards the point where you are finding the field. Thumb in the direction of current. Open the fingers in the direction of the point where you are finding the field. Finger will tell you at this point in this direction I want to find the field. Then the direction of facing palm will give you the direction of magnetic field. Just imagine the moment you do current, point towards right, then imagine a bullet is coming out of your palm. Then bullet will go in inward direction. That means field is inward. The field is inward. Magnitude wise, mu naught I by 4 by d sine alpha plus sine beta. But what if it is a semi-infinite wire? Semi-infinite means one end we are able to see, another end we are not able to see. So if you join one line if you join, so D is same, perpendicular is same, and the line joining the end is also same. So one angle will be 0. But if you start joining the other end, which is very, very far, so the line will go like this. If the line joining are where they meet is very far, then these two lines will seem parallel. That means this angle will be 90 degree. So one will be 90, one will be 0. If you put 90, 1 plus 0, mu naught I by 4 pi d, direction wise same. But this is the most important case. Remaining two, they may ask, they may not ask. But this one they will always ask, which is the case of infinite wire. In infinite wire, if you try to join the upper end, which is very far, lower end is also very far. Both sides are very far. That means both angle are 90 degree. Then you will get sine 90 plus sine 90, mu naught I by 2 pi d. I hope you remember this formula. You remember this formula, right? Formula of field due to ideal solenoid, it is mu naught Ni, where N is number of turns per unit length. Field is uniform. Here toroid, the field is mu naught Ni by 2 pi r. You can think a toroid is nothing but a bent solenoid. Belt solenoid. What is the ideal solenoid? When the length of the solenoid is much greater than the radius of the solenoid. The longitudinal dimension is much greater than the transverse dimension. Longitudinal dimension is much greater than the transverse dimension. We call it ideal solenoid. See, what is R here in this formula? R is the average radius. Means from center to the midway between. So if they give radius of a toroid is given, you just take it. But sometimes in the question, they will give you inner radius is 20 centimeter. Inner radius is 20 centimeter. And they will say outer radius is 22 centimeter. Outer radius is 22 centimeter. In that case, sir, what to take? You take average, 21 centimeter. You take average, A plus B by 2, 21 centimeter. But in those questions, but most of the question, they will give you the radius of the toroid, not inner or outer, radius. So radius given means mean radius is given. Directly you have to put that data. Coming to the force, magnetic force on a moving charge. Force on a moving charge is given as Q into V cross B. We remember Q into V cross B, where magnitude will be V cross B, expansion will be VB sine theta, VB sine theta. So here is velocity, here it is magnetic field. Angle between velocity and magnetic field is theta. Angle between velocity and magnetic field is theta. It can be 0, 180, 90, any angle. Then it is written as QVB sine theta. But if you see this a special case, if theta is 0 or 180, then sine 0 is 0, sine 180 is also 0. That means magnetic force will be 0. That means although there is charge, there is magnetic field, there is velocity, means charge is moving in a magnetic field, but still magnetic force can be 0. Hai magnetic force can be 0. But let's say it is not 0. If it is not 0, then magnetic force will be always perpendicular to both velocity and magnetic field due to the cross product. Perpendicular to both velocity and magnetic field. It is perpendicular to magnetic field, that is not important. It is perpendicular to velocity, that point is very, very, very important. Because if a force is perpendicular to velocity, then the force cannot change its magnitude. If a force is perpendicular to velocity, it can never change its magnitude, it can only change its direction. Means it can never change its speed, it can never change its kinetic energy. But since it can change its direction, so it can change its velocity, it can change its momentum. Similarly, since it is always perpendicular, the work done by magnetic force is always 0. And work done by magnetic force is frame dependent also. Because magnetic force is itself frame dependent, because the velocity is frame dependent. Relative velocity. Velocity not an absolute quantity. Velocity from different frame will be different. So magnetic force from different frame will be different. Now what the special cases? If you put theta equal to 0 degree or 180 degree, put theta equal to 0 degree or 180 degree, then magnetic force will be 0 and the particle will go in a straight line with constant velocity. If you throw the particle parallel or anti-parallel to the magnetic field, there's a magnetic field in this direction. If you throw a particle same direction or opposite direction, it will keep moving in that direction because the magnetic force will be 0. But if you put theta equal to 90 degree beta, then this is a case of uniform circular motion. Uniform, speed will remain constant. Speed will remain constant. Then if it is going in a circle, then it must have some radius. Radius formula we have derived, mv by qv. mv you can write momentum. Momentum you can write under root 2m kinetic energy. Under root 2m kinetic energy. Sometimes they will say the charge is accelerated through a potential difference of v volt. Charge is accelerated through a potential difference of v naught volt. Then kinetic energy will be written as q into v naught. If some charge is accelerated through potential difference v naught, then kinetic energy will be written as q into v naught. Then root q and q will get partially cancelled out. Then they ask this question: electron, proton, alpha particle, deuteron, these things are thrown. These things are thrown in the same magnetic field. Find the ratio of the radii of the path traveled by them. You must have encountered that question. Very, very, very important. So I have combined them in one group. If different charged particles thrown in same magnetic field, 4 types of question they can ask you. All the charged particles are thrown with same velocity, same kinetic energy, same momentum, or might be accelerated through same potential difference. So, if you look here, if they are thrown with same velocity in the same magnetic field, then if they say proton and alpha particle, then what things are different for proton and alpha particle? Velocity same in the question, magnetic field same, thrown in the same magnetic field. Then what are different? Their masses are different. Proton and alpha particle masses are different. Proton and alpha particle charges are different, right? So that means R will be, radius will be proportional to m by q. But if they say both are thrown with same momentum, I will use momentum is same, B is same. That means it will only depend on q. It will not depend on the mass. It will only depend on q. If it is accelerated through same potential difference, under root m by q, and same kinetic energy means under root m by q. You got it? 4th type of question they can ask you, please go through it. And then we have 3rd case. If theta is not, I think we have written, if theta is not any special angle, if theta is not 0, not 90, not 180, theta is not 0, not 90, not 180, then this velocity and magnetic field, let's say it is having some angle theta. Velocity and magnetic field having some angle theta. Then this velocity will have two components. One will be V parallel, one will be V perpendicular. And it will have two components. Now due to V parallel, it will start going in a straight line. Due to V perpendicular, it will start going in a circle. So circle followed by a straight line. Circle followed by a straight line. So it will be a helical path. Now, helix also has some radius. Helix has some radius, which is mv perpendicular by qb, because who is responsible for the circular path? V perpendicular, not entire velocity. So here mv perpendicular by qb. But this distance in one time period, how much along the axis it has moved? What is the displacement in one time period? We call it pitch. So pitch is defined as, now who is responsible for this right side motion? V parallel. So we'll say pitch is V parallel into time period. Time period is 2 pi m by qb into V parallel. Then comes the special case of Lorentz force. Lorentz force is nothing but if a charged particle is moving in both electric field and magnetic field combined, then Lorentz force will be the addition of electric force and magnetic force. Just remember, Lorentz force, the net force, is frame independent. Although magnetic force is frame dependent, but the net force, Lorentz force, is frame independent. Again, I can't go why, sir. That we don't have time. Just remember, if they give any theoretical point, just remember, Lorentz force is frame independent. Okay, but magnetic force is frame dependent. Okay. Now in Lorentz force, they ask this a special case: if you throw a charged particle in electric field and magnetic field, both are perpendicular, then in which direction you should throw a charged particle? So that it passes with constant velocity or it passes undeflected. Now for constant velocity, net force should be 0. For constant velocity, net force should be 0. If net force is 0, then E vector will become minus V cross B. Or you can write minus V cross, you can write minus sign means we can reverse it and we can write B cross V. B cross V. So this thing will help you in finding the direction. Like if they say E equal to E naught I cap, B equal to B naught K cap, let's say. And you want to know what is the direction. What is the direction? What direction? So we know the answer will be either J cap or minus J cap. But whether plus or minus, how to decide? So I will write here, understand, I will write here, E vector is what? I cap equal to K. So I will ask K cross. K cross what will give me I? K cross what will give I? So do you think K cross J will give I? No. K cross J will be minus I. So K cross what will give I? So K cross minus J will give I. That means this box will help you in finding the direction of the velocity, and then minimum velocity will be E by B. Minimum velocity will be E by B. It means if it is given, let's say 10 volt per meter, and this is given 2 into 10 to the power minus 5 Tesla. 2 into 10 power minus 5 Tesla, then minimum velocity will be 10 divided by 2 into 10 power minus 5, which will become 5 into 10 power 5 meter per second. This is the minimum velocity we should give. 5 into 10 power 5 meter per second. So we have seen magnetic force on a moving charge. Now it's time to discuss magnetic force on a current carrying wire. Magnetic force on a current carrying wire. If you talk about the small amount, a small small element, ideal. If a small element is placed in a magnetic field, a small current carrying element is placed in a magnetic field. So inside this current, why there is a current? Because there are electrons drifting. So current in a wire is nothing but moving charges. So a current carrying wire placed in a magnetic field is nothing but moving charges in a magnetic field because the electrons are drifting. Okay? So that means moving charges will experience a force in the magnetic field as well as current carrying wire will also experience magnetic force in the magnetic field. And as I said, if you remember, replace ideal with QV. If you remember, then their force was QV cross B. Then here I will say the force is ideal cross B. I hope you understand. Replace ideal with QV. I told you, right? So it will be ideal cross B. For a straight wire in uniform field, you will integrate this, and if field is uniform, I is steady. We always talk about a steady current. I is constant. If I is changing with time, we can't apply anything. We can't apply Biot-Savart law. We can't apply Ampere circuit law. We can't apply anything. We are only discussing a steady current. Always remember it. We are only discussing steady current means I is not changing with time. Okay. So for a straight wire in uniform field, F equal to I L cross B. Because in B will be outside, I will be outside, then only integration DL will give you L. But only for a straight wire, I L cross B. Then sir, what will happen for curved wire? But in uniform field, so we will replace the curved wire with a straight wire, and instead of taking the length of the curved wire, I will take the length of the straight wire, which is L effective. It will become I into L effective cross B. Means I will convert the question of a curved wire into a question of straight wire. Then sir, what will happen? Closed loop. The closed loop in, please always remember, in uniform field. So since L effective will become 0. But always remember uniform. Don't take it granted. Uniform field. All these points are valid only for uniform field. This is okay. You can apply everywhere. Uniform, non-uniform, the basic. But the net force must be found, or these formula are only valid for uniform field. What is the force between two infinite wires? What is the force between two infinite wires? So first force per unit length is given as mu naught I1 I2 divided by 2 pi d. Mu naught I1 I2 divided by 2 pi d. If the currents are in same direction, parallel, attractive force. If they are opposite direction, anti-parallel, then it will be repulsive force. That marks the end of moving charges and magnetism. Now in the next chapter, magnetism and matter. Just last 15 minutes you give me. Remaining we will discuss later on. EMI and AC we will discuss later on. Don't worry, I will not extend because I know it's time for lunch. You are here since 7:30 almost. So 6 hours will be there. Okay, so I know the mind is also getting saturated. Okay, so let me cover this magnetism and matter, then we will take the break. And remaining, I will decide when to complete the EMI and AC part. Now in magnetism and matter, two concepts are there. The first is the concept of bar magnet. It will not take that much of time, bar magnet. And another one, magnetic properties, where we have to discuss paramagnetism, diamagnetism, and ferromagnetism, some properties. Okay? Come on. Thoda sa. Because I started the class around 11 o'clock, so 2 hours only. So I think one more hour is required, or 1 hour 30 minutes. Okay, bacha? It is possible then today, otherwise we will take on the third day. Magnetism and matter. First one is bar magnet. Second one is that paramagnetism, ferromagnetism, and diamagnetism. So first of all, we will start with the term magnetic dipole moment. Magnetic dipole moment. Sir, magnetic dipole? डाइपोल इन इलेक्ट्रोस्टैट अभी बताया है ना, आई टोल्ड यू कि इक्वल एंड अपोजिट चार्जेस नोन एज डाइपोल, बट सिंस this is charge, electric charge, so we call it electric dipole. Now we will not call it dipole only, we will call it electric dipole. Then magnetic dipole. So what do you mean by magnetic dipole? Actually two things can be known as magnetic dipole. One is bar magnet and one is current carrying coil. Because both magnetism are similar. The magnetic field lines due to a bar magnet and magnetic field lines due to a current carrying coil has lot of similarity, especially when you talk about far points, है ना, they have a lot of similarity. ठीक है, that's why bar magnet has all the right to be known as dipole. Di means two, pole means opposite nature. So bar magnet has south pole and north pole. It has all right to be known as a dipole because it has something different, है ना, something of two opposite nature, south pole and north pole, two poles, dipole. Current carrying coil, why you are calling it a magnetic dipole? Because its magnetism is similar to bar magnet. Okay, so remember, magnetic dipole, either current carrying coil will be known as magnetic dipole or a bar magnet will be known as magnetic dipole, and every dipole has some dipole moment, है ना? So these two will have some magnetic dipole moment. What is magnetic dipole moment of a current carrying coil? NIA, where A is the area enclosed by coil. How to find the direction? So direction, right hand thumb rule, just like you find the magnetic field, है ना, right hand thumb rule. Bar magnet, what is magnetic dipole moment? So just like here, Q into D, here we write small m into L. What is small m? We call it magnetic charge. This is electric charge. Small m we call magnetic charge, also known as pole strength. Also known as pole strength, है ना? Direction, so if you remember, direction was from negative to positive charge. Here direction will be south to north pole. Direction will be from south to north pole. So here direction, right hand thumb rule, here direction south to north pole. Okay, bachawadi? Now that's why in some numerical of EMI you will find a current carrying coil, they will replace with a bar magnet, something like this. So any current carrying coil, not only circle, square, any shape, if it is a current carrying coil, you can replace it with a bar magnet. You can replace it with a bar magnet, but you have to place the bar magnet along the axis of the coil so that the M vector coincide. So that the M vector coincide means if it is anti-clockwise current, so M vector will be up, then I will take polarity like this so that the M vector is up. That's why in some question we replace current carrying coil with a bar magnet. Now, what type of question they ask? They will say a circular coil of 1 turn had been changed into a circular coil of n turns. Then here magnetic dipole moment is M. Then what will magnetic dipole moment here? We need break. Bas, give me 10 minutes. Then after 10 minutes, you can have lunch. This is 1 turn, this is n turns. M will change to M dash. What will be M dash? Understand here. M is nothing but I into A. Hana? M dash is Ni A dash. Right? Now, since same wire is used, we can say that 2 pi r equal to, if you say the radius is capital R, here you say the radius is small r. So you will write n into 2 pi r dash or 2 pi small r. If you put here n, I remains same. Area we will write, here it is I into pi capital R square. You will write pi small r square I will write, but I will write here r square by n square, which is m by n. M dash is coming out to be m by n. Check if I have done any mistake. I equated the circumference, the length of the wire, because same wire we are using. So here length of the wire, one turn, 2 pi r. Here 2 pi r, but total n turns, so 2 pi r into n. So small r we will get capital R by n. I have put here area capital R by n, and then I have multiplied n also. Okay? So I think it is correct. It is m by n. Next question. One turn, but circle had been transformed into square, same wire, means length is constant. Then what is the ratio of m1 and m2? So we will write m1 as I into pi r square, and if I say the length is L, I into L square. But we know 2 pi r equal to 2 pi r, the circumference equal to perimeter, which is 4L. So L we will write pi r by 2. If you put here m2, we will get pi square r square by 4. So if you take m1 by m2, I pi r square will get cancel out and will become 4 by pi. It will become 4 by pi. Here they ask you this question, key, if it is a bar magnet is cut, total was m, but if it is cut, then the individual part will have how much? M by 2. If it is cut equal part, then m by 2. Because remember, like this magnetic dipole moment is directly proportional to the volume. Directly proportional to the volume. If the volume is half, then magnetic dipole moment will also become half. Whether you cut it along this longitudinal direction or transverse direction, here also the left part will have m by 2, m by 2. Here also, because we have cut it symmetrically, m by 2, m by 2. Doesn't matter how do you cut it. Equal to m by 2, m by 2. Then they will say there is a south pole, north pole. Now it is bent in this form, south pole and north pole. Find m dash. Find m dash. Find m dash. So understand here. Earlier m was, you can say small m into L. Here m will be this line joining the south and north pole, which is displacement in a circular motion, if you remember, which can be written as small m into displacement, if you remember, in circular motion, 2r sine theta by 2. But L is what, beta? L is this length only, no? L is this length. This L is curved length, which is r theta. So this is m dash. So m dash, if you divide it, it will become sine theta by 2 divided by theta by 2. So remember it. Directly remember it. M dash equal to m into sine theta by 2 divided by theta by 2, where theta we will take in radian. Theta we will take in radian. Means if it is 60 degree, what I am trying to say, if theta is 60 degree, so m dash we will write m sine 60 will be root 3 by 2 divided by pi by 3 and by 2, pi by 6. So whatever it is, okay? I think it will be 3 root 3 by pi m. Check it. But here if it is length L, then here the same bar magnet has been bent. Bar magnet has been bent in the form of L shape. In the form of L shape. So this is L, then this one is L by 2 and L by 2. L by 2, L by 2. Then the dipole moment will be like this, south and north in this direction. So L by 2, it will become L by root 2. So m dash, here it is small m into L, but here m into L by root 2. So we can say it's m by root 2. Come on. M is small m into L, m dash is small m into L by root 2. Here length L by root 2. Generally, a student think, ki sir, m root 2. No. Okay, m root 2, but m is this and this. It is m, so half part will become m by 2, m by 2. Then you can take m by 2 root 2, which is m by root 2. Now, if you place a magnetic dipole, in a uniform field, now I'm saying magnetic dipole, that means I'm covering two cases at once. Bar magnet as well as a current carrying coil. Either you place a bar magnet, M vector, in a magnetic field, or you place a current carrying coil, M vector, in a magnetic field. Let's say the M vector and magnetic field is making an angle theta out of here, theta between them. Okay. Then just like electric dipole in uniform electric field, same formula will be magnetic dipole in uniform magnetic field. Net force by the magnetic force on the coil and the bar magnet will be 0. If the field is uniform, torque will be written as M cross B. Just like P cross E, we will write M cross B. And then potential energy, if you remember, we used to write minus P dot E. We will write here minus M dot B. And work done external, P cos theta 1 minus cos theta 2. We will write here MB cos theta 1 minus cos theta 2. And time period of a small oscillation is 2 pi under root I by MB. Where I is the moment of inertia of the loop and moment of inertia of the bar magnet. Okay? If they say, what is the magnetic field due to a bar magnet? At an axial point, so axial point M vector this side, the axial point will be 2 K of magnetism, you can say. This is the K of magnetism, mu naught by 4 pi, 2 K P. P means M by RQ, axial point. And field will be parallel to M vector. Field will be parallel to M vector. But if they say this point, at a distance R, so here field will be anti-parallel to M vector, and this field at equatorial point, this is field at axial point. Field at equatorial, we will write Kp by RQ. K means mu naught by 4 pi. P means M by RQ. And field at equatorial point will be anti-parallel to the magnetic dipole moment. Means any question of bar magnet you can convert into the question of electric dipole. If you're not comfortable in bar magnet and if you are comfortable in electric dipole, must convert the question of bar magnet in electric dipole. Not comfortable in both, then we can't do anything. And the last thing of this chapter. Paramagnetic material, diamagnetic material. What are the different properties? Paramagnetic material are weakly attracted towards the magnet. Diamagnetic material are weakly repelled by the magnet. Why? Because what is the reason behind this? Reason is here, point number 3. Because it slowly moves from weaker part to the stronger part of the magnetic field. Weaker part to the stronger part of the magnetic field. This is the property of paramagnetic material. To understand, if you keep a magnet over here, beta, south and north, and if you bring up paramagnetic material, then you know, as you go away from the magnet, the field will decrease. And as you go towards the magnet, field will increase. If you go away from the magnet, field will decrease. Coming towards the magnet, field will increase. And paramagnetic material, let's say this is a paramagnetic material. It has a tendency to go from low magnetic field to high magnetic field. Low to high. And low is away, high is near. So it will go from low to high magnetic field. Means it will be going towards the magnet. Low to high means it will be going towards the magnet. So we can say that magnet attracts paramagnetic material. But this attraction is very weak. है ना? You won't be doing है ना on casually. If you do casual experiment, you will never get it. You hang a paramagnetic material from a thread, and now bring a magnet very carefully. You will observe a little bit of deflection. Or you take a paramagnetic material, make it float on a water. Like you take a cardboard, on the cardboard you keep a paramagnetic material, and then you bring a magnet. That cardboard will move in the same direction of the magnet. Hana? But if you keep the paramagnetic material on the table and keeping a magnet, and they're asking, sir, it is not getting attracted, you lied in the class. By friction is there, yaar. Friction is there. Although there is attraction, but attraction is so weak, it is not able to overcome friction. That's why you're not able to feel any attraction over there. Is this point clear? So if you do careful experiment, you will find the magnet attracts the paramagnetic material, which is, and the reason you can say कि paramagnetic material, है ना? They ask this, na assertion reason. If the assertion is कि paramagnetic materials are weakly attracted towards the magnet, then the reason is because they have a weak tendency of moving from low magnetic field to high magnetic field region, and it is just reverse. They are weakly repelled. Why? Because they have a tendency to go from strong to weak part of the magnetic field. They have a tendency to go from strong part to weak part. That's why if this is a magnet, this one is a magnet, diamagnetic material, so it will try to go from high magnetic field to low magnetic field, means away from the magnet. Clear, bacha body? But weak repulsion will be there. Weak. Again, you have to do the experiment very, very, very carefully, very precisely. Okay. Ferromagnetic material is nothing but a hyper case of paramagnetism. Ferromagnetism is nothing but amplified case of paramagnetism. Okay? So whatever happen, same thing, but on a larger scale. Like this is weakly attracted, this one will be strongly attracted. Slowly moves, quickly moves. Same. Okay? Now, freely suspended paramagnetic material aligns itself parallel to the applied magnetic field. If you apply a magnetic field like this, and paramagnetic material will align like this, parallel to the field. But if you apply a field, then diamagnetic material will align itself perpendicular. Means, if magnetic field in this room is right side, right or left, whatever you are able to see, right or left, then paramagnetic material will orient like this. But a diamagnetic material, if field is right, diamagnetic material will align itself perpendicular to the field. Remember this point? Okay? Bachawadi. Small point, let me discuss. Dielectric, I told you, if you keep a dielectric in an external field, electric field, similarly, if you keep a paramagnetic material in external field B0, something happens inside such that it produces B induced in the same direction. Such that it produces B induced in the same direction, and the net B increases. And the net B increases. This happens in paramagnetism, just like dielectric. But if you keep a diamagnetic material so here B is more than B0. Here net field will be less than B0. This is the case of diamagnetism. So we say it gets magnetized in the same direction of external field. Here we say it gets magnetized in the opposite direction of B0. So paramagnetic material gets magnetized in the same direction of external field. Diamagnetic material gets magnetized in the opposite direction of magnetic field. Opposite direction of magnetic field. Okay? Acquire weak magnetization in the same direction of magnetic field. This one acquire weak magnetization in opposite direction of magnetic field. I hope you understand this. Okay, then you go through these points. In your notes also it will be there. Understand here? Mu, permeability is more than mu naught. Permeability is less than mu naught for dia. Permeability. What is the meaning of permeability? The meaning of permeability is the ability of magnetic field lines to permeate, to penetrate a medium. To penetrate a medium. Understand this? If it is a paramagnetic material, if it is a paramagnetic material, and the field lines were like this, aisa. So, and here field was B naught, outside field is B naught, but inside field I told you, it will be more than B naught, because B induced will be in the same direction. Then don't you think, here field, if field is more inside, then here field lines should be crowded. Field lines should be crowded. So that means some field lines which were supposed to go out, some field lines which are supposed to go out, it will be attracted like this. It will be attracted like this. So some field lines which are supposed to go outside will be also go inside. Means number of field lines in the vacuum in the same space will be less, and in the material, in the paramagnetic material, it will be more. That means field lines are attracted. We say the field lines are attracted. And this is the meaning of permeability. In this, last thing, in this space, some field lines are going, like upper, this one is not going, but here it is going. That means more field lines are penetrating the medium as compared to the vacuum. Same space of vacuum, less number of field lines are penetrating. Same space in the medium, more number of field lines are penetrating. So the ability of field lines to permeate a medium is known as permeability of the medium. How much magnetic field lines are permeating, penetrating through the medium, passing through the medium. So in paramagnetic, since inside material magnetic field is more, so more number of field lines will pass. And in diamagnetic, field is less than B naught. So some magnetic field lines which were supposed to enter, these field lines were supposed to enter, but it will not enter. That means less number of field lines will enter. That means permeability is low. So that's why we say if permeability of the diamagnetic is less than vacuum, permeability of paramagnetic is more than permeability of the vacuum, and in ferromagnetic it will be much more. That's why relative, we say it's less than 1, relative more than 1. In ferromagnetic we say relative is much greater than 1. Okay? So we will keep our discussion till here. Remaining I will inform. Okay, don't worry, I will cover the next 2 chapters, which is EMI and AC. EMI and AC. Go have your lunch. Thank you for your time and patience. Please share that PDF in app. Okay, I will ask them to share the PDF in the app. Don't worry about that. You will get it. Okay, I hope you have learned something. Ask them to send note video, otherwise they will delay a lot. Okay, I will ask right now only. Don't worry. Chale, bachawadi, take care. We will meet soon. Tada, bye bye.